Chapter 5, Energy, Part 1 of 3. The questions that we'll answer in this video: what is energy? What are different forms of energy? What is heat? What are the different types of temperature scales? What are the units of energy and how is energy calculated? And what are the laws of thermodynamics? Forms of energy: potential energy. There are four types of potential energy: potential chemical energy, potential mechanical energy, potential nuclear energy, and potential gravitational energy. Potential chemical energy. Potential chemical energy is energy stored in the chemical bonds of molecules. Food, gasoline, natural gas, propane, and biomass are all examples of potential chemical energy. Potential mechanical energy. Potential mechanical energy is energy that is stored in an object because of the application of a force. A catapult is a good example of potential mechanical energy. Potential nuclear energy. Potential nuclear energy is energy that is stored in the nucleus of an atom. Nuclear power plants harness a tiny portion of this energy by splitting the nucleus of uranium atom in a process called nuclear fission. Potential gravitational energy. Potential gravitational energy is energy stored in an object because of an object's position or place in a gravitational field. A roller coaster takes advantage of gravity. As you are towed up the first hill of the roller coaster, you gain potential gravitational energy. Kinetic energy. There are five types of kinetic energy: electrical energy, radiant energy, thermal energy, motion energy, and sound energy. Electrical energy. Electrical energy is the flow of tiny charged particles called electrons. Electricity provides the energy we use every day for lighting, cooking, heating, and entertainment. Radiant energy. Radiant energy is electromagnetic energy that travels in waves. Examples of radiant energy are light, radio waves, microwaves, and X-rays. Thermal energy. Thermal energy is the internal energy of a body or a substance resulting from the vibration and movement of atoms and molecules. You can think of atoms and molecules as bumper cars. If they're moving slowly, there are few collisions. If they're moving quickly, there are more collisions. Everything in the universe has some thermal energy because an absence of thermal energy implies a temperature of absolute zero. Motion energy. Motion energy is the kinetic energy contained in an object or substance that is moving. Examples include the movement of a train, a baseball moving through the air, the flight of a rocket are all examples of motion energy. Sound energy. Sound energy is energy that travels in longitudinal waves that expand and compress the substances it travels through. Examples include audible sound and ultrasound. Heat. Heat is the flow or potential flow of energy from a higher temperature substance to a lower temperature substance. Heat transfer. Heat always flows from hot to cold. Heat transfer can occur in three forms: conduction, convection, and radiation. Conduction. The kinetic energy of the molecules is transferred through a process called thermal conduction. When thermal conduction occurs, heat is transferred within a substance through particle-particle collision. All materials conduct heat to some degree, but some materials are better thermal conductors than others. Materials such as glass and styrofoam are poor conductors of heat, whereas metals such as steel and aluminum are excellent conductors. Convection. The transfer of heat through the movement of warmed matter in a fluid is called convection. The process of convection. Warm fluid rises and cool fluid falls. This process within the mantle of the Earth is thought to be how the tectonic plates move. Hot air balloons also embrace this concept, heating the air inside the balloon, then it's trapped as it begins to rise. Radiation. When you warm a meal in the microwave, play outside on a sunny day, get an X-ray, or listen to the radio, you are being bombarded with radiation. Radiation is the ability to transfer energy through empty space, unlike convection and conduction, which both need matter to transfer energy. Thermal radiation is the transfer of heat from one place to another through electromagnetic waves. How temperature and kinetic energy are related. There are approximately 7.9 times 10 to the 24th molecules of water in 1 cup of water. Measuring the temperature of water is actually measuring the average kinetic energy of all those molecules. When the temperature of a material increases, the molecules spin, vibrate, and slam against each other more often and with greater force. As the temperature decreases, the movement decreases. Temperature scales Fahrenheit and Celsius. The Fahrenheit scale sets the boiling point of water equal to 212 degrees Fahrenheit and the freezing point of water at 32 degrees Fahrenheit. The Celsius scale sets the boiling point of water to 100 degrees Celsius and the freezing point of water to 0 degrees Celsius. Kelvin scale. The Kelvin scale is a widely used scale by engineers and scientists. Each degree on the scale is called a Kelvin, or K. A temperature of 300 kelvins would be 300 Kelvin, not 300 degrees Kelvin. 1 Kelvin is equal to 1 degree Celsius. The lowest temperature on the Kelvin scale is absolute zero, or the point at which all movement of particles stops. There is no negative Kelvin. To convert from Celsius to Kelvin, add 273.15 to the Celsius value. And then down here we have a formula. Kelvin equals Celsius plus 273.15. Formula for converting from Celsius to Fahrenheit. Here we have our Fahrenheit temperature, which is equal to 9/5 the Celsius temperature plus 32. And you could plug in the Celsius temperature in there to get the Fahrenheit temperature. You could work backwards that way if you needed to. Finding changes in temperature. Change in temperature indicates how much heat a system has gained or lost. When the temperature of a system increases, it is a positive change in temperature. When the temperature of a system decreases, it is a negative change in temperature. The British Thermal Unit, or BTU. The energy in 1 BTU is capable of raising the temperature of 1 pound of water 1 degree Fahrenheit. It would take 10 BTUs of energy to raise the temperature of 10 pounds of water by 1 degree Fahrenheit, or 1 pound 10 degrees Fahrenheit. Another unit of energy that appears on natural gas utility bills in the US is the therm. 100,000 British thermal units is equal to 1 therm. Calculating the heat needed to change temperature. To calculate how much heat is required to change a substance, you must know the mass of the substance, the desired change in temperature, and the specific heat capacity of that substance. Specific heat capacity is a measure of a substance's ability to absorb thermal energy. The amount of heat, Q, is equal to the mass, M, of the substance times the substance's specific heat capacity, C, times the substance change in temperature, or delta T. So there's two different formulas down here. Q equals mc delta T, so the mass times the heat capacity times the change in temperature, or we could write it Q equals mc, and then in parentheses, the final temperature minus the initial temperature. The joule. The SI unit for work is the joule. A joule is 1 Newton of force acting over 1 meter. The calorie. Calorie is equivalent to 4.19 joules. 1 calorie is equal to the amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. This ends part 1.